Welcome back to another training session in OpenDSS-G. In this video, we're going to talk about a tool that was recently added to the tool suite that we have in OpenDSS-G, and it's called the voltage recorder. This recorder allows us to record all the voltages across the feeder while simulating every simulation step. This is something that can be done only when using external interfaces, like for example COM interface or DLL. And in this case, we wanted to implement that in OpenDSS-G to make it easy to use and also to provide some nice graphics that can be probably important for certain types of studies. So for that, we have the EPRI Circuit 5, a circuit that probably you guys know well. And we're going into the simulator. Here we're going to do a yearly simulation, only 2 days, 48 hours. And as you can see in the configuration menu, there's an option called voltage recording. We're going to enable that one just by clicking on it. And with that, we're going to go home. So now the next step will be just to run the simulation. We got it there. So 2 days already done. And then we're going to go into graphics, and there we're going to see a new graphic that is on below of the menu bar, and it's called the voltage trend in time. So we're going to click on it, and we're going to have a very nice graph made with block and whiskers, in which we have at the bottom the hour in which all the voltages were taken. And we're going to see also information about the minimum, the maximum, and the average, which is, well, very nice because it covers all the voltages across the feeder. Now, on the title of the window, you can see that it says all phases, which means you can work with all the phases across the feeder, or you can go with specific phases. For example, in this case, let's suppose we want to bring together and compare the trend in terms of the voltages across the feeder for phases 1 and 2. So I can just open another block and whiskers graph, and what I'm going to do is the following. On the one on the top, I'm going to go with phase 1, and the one at the bottom, I'm going to go with phase 2. So to do that, I'll just go to the graph on top, right click on top of it, and select the option that says plot specific phase. Now you can see that the title of the window says phase 1, which is the one I just entered. Now I'm going to go to the one at the bottom, and I'm going to enter 2. And now we're seeing phase 2 at the bottom. So we can see that there's some definitely a difference between phases that can be well, identified through the graphics. And well, of course, everything is labeled on the window title, telling us what's the phase we're using. Also, we can export the voltages in case I want to work with them later or do my own processing. So I can just right click, select export the content. Once I've selected the destination of the file, I'll just can go ahead and open it. In this case, I'm opening it in Excel. As you can see, we have on the first row the labels. So we have the time in hours, and then we have the name of all the different buses, and well, buses in terms of nodes, because we have every node differentiated by name. And for example, we can recreate the behavior in time for the 48 hours at will. We are again including all the information for all the buses, and this is very interesting. So now let's suppose the following case. Let's suppose we're going to do not 48 hours, but a whole year. We're going to keep the voltage recording on, and we're going to see what happens. So we're going to start the simulation. We can see that everything is running well. With the magic of video editing tools, we're going to accelerate the simulation, so we're about to get to the end. Of course, the voltage recorded also is supported by parallel processing, so it's not a problem if you use temporal parallelization. And now when we go to the graph, we'll see that we're not drawing blocks and whiskers because they will not fit in the graph. Instead, we're graphing 3 different waveforms. One for the maximum, one for the mean, and the other one for the minimum, for all or single phases. We can change the colors, hide plots, etc., depending on what I'm trying to do. So here in this case, we're doing the same. We're just bringing together 2 different plots, and we can also select the phases that we want to see. So we're going to do exactly the same exercise we did before. In this case, we're seeing all the phases. Now I'm gonna change that for plotting only phase 2 and phase 1. Phase 1 on the top, phase 2 at the bottom. And we can see that there's a difference in terms of voltages. Actually, in phase 2, we're reporting smaller voltages within this range I'm looking here, which is our 800 and 1667. So I'm going to bring the plot at the top to the same range, so 800, and I'm going to put the upper limit as the same. Again, the graphics are very flexible, so you can just go ahead and do that, and change the ranges, and I'm going to put everything in terms of the same magnitude. And we can see the difference between the two phases using this interesting tool. Again, we can also export the report. I'm going to export it to an Excel file. Of course, this may take a little while because we're exporting a lot of data, but it takes a little while, but it's not terribly bad. Of course, it all depends on the amount of years or the amount of time or samples that you're taking. At the end, it's going to tell us where the file is located. So we're going to open the file. It will take a little while, but thanks to the magic of video editing, we can also accelerate that. So here it is. We have, again, at the first row, the labels for time and all the different nodes on the system. And we can see that in terms of time, we have the 8760. Well, in this case, it says 8808, which is, well, 48 hours plus 8760, which is what we had before. And with this, you can just go ahead and, for example, like I did in the previous file that we generated, try to recreate the voltage waveform for that specific set of nodes on that bus. With that, we should be good. So you have all the information you need for post processing with your preferred programming language.